by 2/10 of a meter per second.
Where?
Which is what you had before.
I said for each,
It's up
at
there.
each second, my velocity increased at 2/10 of a meter per second.
Second square.
No, I said my velocity for each second increased at a rate of 2/10 of a meter per second. My acceleration was 2/10 of a meter per second squared. But in my sad little brain, I don't think in meters per second squared. I think about meters per second per second. So my change in velocity was 0.2 or 2/10 of a meters per second each second.
So I would put like a.
No.
Can I put
Yeah,
M
that's
over
what
S
I
over
said.
S?
Meters per second
Yes,
squared.
it's meters per
Because it's
second per second.
Over S.
So that's why we
Yes.
squared this down.
And if you divide out, I don't know what that is.
So there's a big difference in being able to calculate and do the math and understanding what you're doing. So
Or riddles.
there is.
As we saw today.
Yes. So meters per second squared is all well and good, but unless you don't know what that means.
So I finally got something out there, now I have to say it. Remember, velocity is the change of change.
Okay, we want to end up with
Changing in position.
two things. Number one, did you hear the depth of your conversations or discussions or arguments, whatever you want to call it?
Frustration.
That's what you should be hearing from your students. That kind of wrestling with ideas, concepts, and developing that depth of understanding. And if you don't do the planning that requires them to do that, and the expectation that they do that, and then and the training, because they're not accustomed to having these kinds of in-depth conversations. I can't think of any classroom I have been in that I have heard this kind of depth of conversation on any topic. It's just not out there, along with some other things. So your experience with having this kind of depth of conversation, I hope you take back to your classroom to see that there are times, not every concept, but there are times when you should train your students how to do this and expect them to do it. And there are ways that you can do that. I know, I don't have the information on the top of my head, but I know from experience in some of my own classrooms, sometimes it's just a matter of giving the information, the procedures or whatever you want to do, and then just simply wait, and with the expectation that they're going to, and maybe with cueing with some questions, that you need to think about, how can I engender this kind of depth of conversation? So it's going to have to be very structured at first. Lots of question. Think about your own experience of how did your group get to those depths of conversations? What kind of questions did it take? What kind of encouragement? What did Laura say or do or not say or not do that allowed you, encouraged you, required you to do that? As you might suspect, Russell and I were in the back of the room and we were having our own conversations. And so Russell was kind of pondering some ideas about where to put these two graphs here. And so you see I have this little arrow right here where it says this way. So we talked about moving this graph down here below this one, and what that might show students, or might allow students to see, versus having it sideways. Well, the first thing I told him, I said, well, teachers are gonna put it this way because it takes less paper. Right?
Yes.
Okay.
You could do a
That's
half
right,
sheet
we
and
have,
rotate it.
we have restrictions. But Russell, you wanna come on up here? Anyway, so what he explained to me, because I hadn't thought about it, was that if we actually put the both directions, so you would have this one as your top left position, then you would have velocity, and then you would have your acceleration graph over here, which doesn't show, but you would also have your velocity graph down here, and your it's not showing. So velocity graph below that, and then acceleration graph below that. So you'd have a horizontal look and a vertical look. And then, so Russell, you want to go ahead with him about looking at time crosses, all right? So I don't screw it up.
Okay, let's see. We have a fresh piece of paper I can start with?
There's,
One more paper?
Dr. West.
Dr. West, to
There's
your left.
open some- there's
To
some
your left.
open-
Well, that's graph paper. I was trying to get him something with less.
Yeah, because
Lines.
I use typing paper myself because I don't like
Oh,
lines
do
at
you
all.
want,
Oh, well, you did
That's
anyway.
okay. Because you know these are rules? This is ruled paper. I don't obey the rules. Because, especially just because they're rules.
See what y'all missed out on having Russell?
There we go, okay. This is the thing, is that what I've been taught and what I've used in my classes is to have the position versus time, and I'll just put X and T there, and then the velocity versus time, and the acceleration versus time this way. Now, one advantage of this is the main advantage, is that the times line up. So that you could say, at this time, something's at a certain position, and at that same time, the velocity, and at the same time, the acceleration. I think, yes, it's got an advantage. One is that you don't actually have to put units on them anymore. You don't have to actually put the time in seconds or anything, a number, because at this time, and then a little later, at this time. You see? And so that you can then just do it conceptually and have people thinking of speeding up, slowing down, and doing things like that. But I've discovered that my students still have the trouble with distinguishing the difference between velocity and acceleration. And in physics, that's the most profound thing, is to get that difference in your mind, to understand acceleration is what's important, not velocity. But to understand what acceleration means. And that's why I like rate of change of position, so I can talk about rate of change of velocity, as opposed to speeding up and slowing down, or deceleration.
Now, Russell, these are freshman
So,
college
back to where we were.
students, so at least
Yeah.
18. Are these non-majors?
Yes.
Non-science majors.
Many of them future
18 years
elementary
old.
school teachers.
Yes, we teach,
Yeah.
our elementary majors are required to take 7 hours of physics, so 3 lecture, and then a 1 hour lab. So these students don't understand it when they get to us after K-12 education.
Now I've got another thought that wants to come
stop
in
it.
real fast. It's a short one though. It has to do with the equal sign. There was one time in one of my classes, I started the first day of the semester, started by talking about equals. For 10 minutes, we talked about what the equal sign meant. And I had 2 students come up to me afterwards and said, thank you. Nobody has ever done that. Never explained the significance of an equal sign in an equation. Because, oh, you got that in 2nd grade. Well, apparently not. But back to the story. Now, I see over here, this, it's gonna cost an awful lot of money to make this, isn't it? Unless I make it smaller, or I get square paper, or bigger paper, or just say, to heck with the cost, it's my students. There we go. Then have the velocity and the accelerations were there. Here, now noticing that to do this with the time is going to be problematic, of you can't just say at the same time. You have to actually have times listed there, but that might not be a bad thing. And I'm wondering if this would help distinguish in the students' minds the difference between the position and the velocity and the acceleration because they can see the labeling. They had to carefully put the labeling here. They have to have this in meters per second or whatever units you get. And this one in
Meters per second per second.
meters per second per second. Did you learn that from me or from somebody else? I always say meters per second when I write that thing, because I don't know what a square second looks like. But the whole point is to get the distinction in the shape of the graphs so that they do not think that this first graph, my students often think that's a picture of the motion. That if you throw a ball and it does this, the position versus time graph should look like that. And then the velocity versus time graph should look like that, a little different. And then the acceleration versus time graph is down an angle. That's because it's going down, see? So in other words, what it means is many of the students, even at the end of my semester, don't understand these at all. They can't graph.
So that was part of the question I was coming up with. When you do linear algebra, or just algebra
Yeah.
one, when you do algebra one, whenever you talk to the students, you're talking usually about distance. And so if you're talking about the distance from the ground, then the ball does go up, stop a little bit, and then come back down. So it does kind of look like a ball throwing. However,
No.
it throws.
Oh, that's it. You throw a ball up and it
Yes.
comes back down, okay?
But that also,
Now, one of the things you said was it goes up and then it stays for a little
Yes.
while and comes back down? Doesn't stay for any time at all.
oh no. But
At an instant in time, its velocity is 0, but its acceleration is not 0. Otherwise, it would stay up there. And how long would it stay up there? Why would it wait for a second? A half a second? What, a week?
2 seconds.
So-
What goes up must come down because it's always accelerating.
How,
But
when you're
back to the story.
doing that, do you get them to understand position and distance isn't the same? Because you do have somewhere, if you're talking about point A to point B, and like I just did and I jumped up and down, they're not getting any closer to point B. So like if they stand in front of a motion detector, you have one that attaches to the calculator,
Right.
and they jumping down in front of it and they realize that the graph is still a straight line because there we're doing speed,
Right.
and so their speed didn't change in relation to the motion detector. How do you start, I know, I'm rambling. I can't figure out how to,
What we do in the physics class is distinguish, pretty early on, I tried to distinguish that there are different, what do you call them, categories of motion, I guess you could say,
okay.
depending on what you're going to consider stationary.
Mm-hmm.
Okay? And that is, there's motion from one place to another. We call it translation, from here to there. And that's the kind of the motion detectors we do.
Yes.
Okay. There's also rotation, that's this kind, and then vibration, that's this kind. So you jumping up and down would be a translation that way,
Okay.
but it would look like a vibration from over here. They'd just say, oh, he's just, something's shaking up there, but it wouldn't be getting closer or
Yes, I'm
farther.
wondering if you had the detector above, it wouldn't look like nothing. That would look
That-
like it's actually going up and down.
Yeah, you would,
So it's
if you had a
all-
motion
yes,
detector
yes,
up above your
okay.
head, it would say you're going toward and away, toward and away,
Right.
toward and away.
Okay.
So it's a matter of what are you gonna call the thing? Because on the small scale, atoms are all wiggling around like that.
Yes, okay.
So back to the story.
Yes, back to this.
Yeah. The whole point behind this was representations. And how do we represent something to students that they can put it in their head in a way that makes connections? Okay? Because what I discovered in my teaching was that what was in my head was totally different than what was in their head. And trying to get it from here to there, when a word to me means a whole bunch of stuff. Because years and years and years of training, I know the jargon. I know the one word that means all this stuff. They learn the word, and they learn it in a context that begins their chunk, their way of putting it together. And that context could be that velocity is what you say whenever you just want to be fancy, as opposed to the word speed. Or at this point in time. Do you mean now? I think that's what, at this point in time means now, I think. So why would you say at this point in time? I don't know. But the beginnings of that chunk and how you attach things to it, I have no idea where they are. And so, the many different ways I can do it that are not lies, not oversimplifications. And so I think a combination of both of those, say, do it this way, also do it that way. And then have them see the connections between the ideas that we're trying to get at.
They should be interpreting the graph, though. You should not tell them what they can see in those. That goes back to the questioning, which we are not seeing in the classroom. We're seeing lots of teacher talk. Very few questions, and if there are questions, they're very low. They're not pre-planned, they're shoot from the hip, they're just, anyway. So,
Also, I'm a very visual learner and visual in my head, but also kinesthetic, I like to move. One of the things is, and I don't know, see, I don't know what level I'm teaching you this stuff at, so I'm just gonna jump to the end. And when we talk about slope of a graph in math world, okay, the slope of the position versus time graph, the slope of it is the velocity. It's the number on the velocity. So that you could have a negative slope with something that's at a positive position. Does that make sense? So instead of the words, and you go, well, negative means this, and negative means this, it's gotta go together. You go, well, can you slope your hand up and down, no matter where you are on this graph? And then when you get to this one, guess what? The slope of the velocity versus time graph is the acceleration. And when you come across here, I don't know if that's as easy to see, to transfer that slope over, wait, how's that go again? I don't know. But it's concept versus number versus words versus pictures.
okay, we're gonna end up right here. So, today, the instruction was where on this continuum? Pictorial and abstract. We are missing the concrete. And that's what that probably Tim and Tanya and Toby remember. And I was telling Russell, one of the best things that we ever did when we were teaching physics, you got that, was that we had motion detectors and we had teachers with cardboard or fiberboard, something that's stiff, and they would see a graph and they would have to replicate that graph, with a motion detector, okay? And they could see it on the screen, so they're trying to replicate this. And it wasn't until the teachers actually did this activity that they figured out what the graphs meant. Otherwise, it was mathematical, memorized, whatever. They did not really understand it. And that's what made it work, and I think that's what's gonna make it work with you guys. When that was also some activities that were used in Algebra 1, when we went into an Algebra 1 class, that we taught them, what is it, Rangers? What is it that?
Yeah, Sonic
What?
Ranger. Or what do you call it?
Anyway, the devices that they would measure that, and so at that point, we gave only the science stuff to the science teachers and not to the math teachers, so the math teachers were borrowing it, and we finally figured out, no, we're giving the equipment to both of them, because in many cases, both the science and the math teachers should be using the same equipment. Yeah. Okay, so this is important. Concrete, pictorial, abstract. We can't begin with the vocabulary. We can't just begin with the pictorial. We have to provide that experience and the sense-making of it. So, you can do labs and there's no sense-making of it. When the kids get finished, they don't know what they've learned. Well, maybe they haven't learned anything, they don't know what they learned. But that sense-making has to occur here. And we are not seeing this. In science, it's supposed to be 40% hands-on. 2 days out of 5, if you talk, about a full period, but we're not necessarily meaning a full period. It's supposed to be this concrete learning experience. That's from the research. This is what is in our best practices. It's been that way for decades. That's at the high school level. What is it that our best practices say at the middle school level? 60%. What at the K-5? 80%. And we're not even seeing 40%. anywhere. But we're seeing lots of vocabulary worksheets and lots of lectures. It's really depressing, and it's depressing to kids. I make my student teachers, Ashley, were you a student for a day? Okay, and Kim, were you a student for a day?
It sucks.
Thank you. You get to be first in line to eat. Yeah, it does. It's a horrible experience being a student. It's no wonder kids are not learning and they hate school.
And their behavior problems because they're told to sit down, be quiet, and do this sheet. Sit down, be quiet, do this sheet.
Yeah, yeah. Okay, so on that good note, let's go eat lunch and Kim gets to be first.
This room will be locked, right?
Yeah, the room will be locked.
Dr. West mentioned that we can go to
Consider retiring.
Well, I'm really tired. My schedule is just here. Not much.
I've only been retired for 5 months. Everybody that says, well, you could do this, you could do this, I go, not yet, not yet, not yet, I'm still figuring it all out.
Well, I'm helping out a son who is 14 years old and has 2-year-old twins. Yeah, so he's a little overwhelmed.
Yeah.
And plus the fact he just had rotator cuff surgery, so, anyway, so, make a long story short.
Last one out, close the door, I'm gonna lock it.
A lot of weekends I leave on Friday, come back on Monday, so that eliminates the Friday and Monday. But, next time I get ready to go to Longhorn, I'll find out for
Yeah,
sure.
turn these out.
Do you know which
How much here for one day?
These.
is it Ashley's class she's doing
I
that?
know I can pay full price for me to go.
Do you know, I'll have to check with Dr. Wesley about which teachers it was that she was interested in working with, but I'll be in touch with you. So before we leave today, let's just change email, should we do it? Okay, so we can do that, we can find out how to do that.
Yeah, and that way we can set something up. And I've got a motorcycle and a bicycle in my feet. That's the way I get around.
Wow, you
So I
are,
can't carry a lot of equipment unless I'm in a car or.
but I got,
Maybe we can.
I don't send it to you.
Oh, we left alone.
But I go, all the schools I visit are on.
Lounge chair,
I do have a
sitting and
pickup.
watching
So we can
video.
load scads and stuff. I mean, if you've got big ramps or
I
whatever.
got rid of most of my stuff when I well, I'm gonna sit here and take it out. I couldn't take it all.
Well, no,
It
you
wasn't
couldn't.
happening. So I took a lot, but I didn't take stuff to teach, the teaching thing. Because, I mean, there's nothing, if I wasn't, I bought it for teaching. That was it. That was the purpose.
Yeah, that's what I asked. She asked me how much.
And I was trying to do
I said, can we cover for one day? She takes back how much?
And pictorial, see, and then the abstract. And
How's
it
your
was
class going this year?
interesting, because some students loved it, many students hated it.
Oh, I
Actually
know.
hated it, because it required them to do some work and
How
thought.
do you do that?
Exactly.
And then when it showed up on the test, they doubly hated it. I thought, just like that. I did not know that the liner value of it, when I bought it, I just needed something
I
tall.
have to, I'm not used to.
And when now I love it.
Same
Oh, it's
prep.
great.
So
My
my
first year I did 7 and 8.
Oh, wow.
You know,
But-
so I don't know.
But.
But it is
You have two
great.
periods
Yeah,
to
exactly.
plan, or 2 periods that you're
But,
not teaching.
anyway, yeah, we'll work something out.
We'll work
And
some-
just
and-
also,
Even
even though my schedule is not scheduled.
So what is that, 3 and 3?
My ability to
3
change.
classes of one and 3
So
classes?
I hate it. I wish it was like all 6 and then all 7, but they do it back and forth. That's whatever the kids schedule them. So I have a first
Oh,
period is 6th
really?
grade.
So you
next
have to
is 7th.
switch gears.
So I'm switching gear subject. If I wants to do like a project or something.
Yeah.
Like, oh man, I want this project or this period to be in groups, and then the next period we can, do different stuff. But it's
Yeah.
and then
My-
so
first year teaching, I taught 2 sections of 6th grade science, 2 sections of 6th grade math, and 2 sections of 7th grade math.
Just
Without a
3
classroom.
preps.
Without a classroom. I didn't have a classroom. So, and 2 of the maths were double blocked, and we had to change classrooms between each block. It was a nightmare.
I mean, like I have, like, I'm
Oh, and my
doing-
desk was by the bathroom, so that was super fun too.
So anything, like I'm doing this, next week, I'm doing, this project, 7th grade working on like percent increase, decrease, you know, tax, discount and stuff. So I normally bring, last year these kids liked it. I just took a lot of my clothes out of my closet, my wife's clothes, I hung them around the classroom. And the kids can, do like a little shopping activity once I teach them how to find a discount, sales tax and stuff. All right, let's go give them some money, you know, and you get X amount of dollars and go buy some stuff. How much can you buy? What do you want? Can you afford it? You know, but then I have, you know, that's great. But then when other kids come in, they'll be, I know my sister, like, what is that? Like, who's closing those? You know, so I'm thinking that's gonna be a potential distraction for them, because they're not doing it. Instead, I'm like, well, it's for 7th grade. But then I've noticed that when I have projects or something to do for one grade level, the other grade level, they're like, I don't know if that makes sense or not.
Yeah.
So I
They
just
want
want
to do with the same project.
yeah, they went, well, let's do this. I want to do what the 7th graders doing. Why y'all doing that? I want to do that. I said, well, no, it's for a different class.
What district are you in?
Divine?
Okay.
Yeah. And then one of those classes is Horizons, and it's regular classes. So
What do you mean Horizon?
Horizon is Divine GT program.
Okay.
So, and I don't want to do why I don't do the same thing I do in a regular math class or a GT class. So that's like another extra prep.
So do they take the same math, the GT kids?
It's still the same math. They get the same book and stuff.
Okay.
My thing is for that class to try to go a little more in depth with it. And then I have a career portfolio for that class. So
Okay.
at the end of every chapter, they'll go, you know, write a paper about a career that they're interested in, do a presentation in class.
Okay.
You know, so in
Cool.
some ways I make it different. But like I said, to answer your question, how do I do it? I know what I know. My experience has been doing it like to teach. When I started teaching, the teach were as they are now. So a lot of my counterparts, well, we didn't used to have to teach this. This used to be here. Well, I don't say that because I don't know how it used to be. So
I know, I don't either. I started teaching the first year they changed those TICs.
I only got lunch, man. I can
Oh, yeah. We're trying to find this one.
look at it.
I'll take mine. Because it should be right here. It's just not coming up.
Okay.
What you may want to do is look at the short courses. And these are individual courses that you can do, which is a little different. That's going to take 6 months to download.
Okay, so yeah, I can
Look at the short courses,
short course.
and then that way you can figure out, oh, it said 6 minutes, that's 20%. You can figure out on Saturday what you would like to go to. And the short courses are normally, I think they're like maybe $10 each.
And I think if that's the case, then it's only like 3 sessions, I think they think, 3 or 4
Yes,
sessions.
3 or 4 on Saturday. and stuff. I think the conference rooms that this door is not locked.
Okay, it's
But you have to
not?
push the button in.
Okay, all right, I'll do that. Thank you.
Oh, even when I push the button in the outside, still, oh no, it's locked, it's not moving. You staying in there, Miss Laura?
I'm coming up, I'm just putting my stuff on,
Okay.
my stuff up.
Oh, belly button. Belly button. Yeah. all about plotting points.
Golly, and you
That was your
know,
whole discussion. Do we connect the
and
points or do we
honestly,
not connect the points?
the point of the, we didn't even get to the lesson.